Welcome all. My name is Varun Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. Today we are going to discuss Boolean algebra simplification. These are the some formulas we are using in the simplification of Boolean functions. Why we need a simplification for the Boolean function? Because of a long or lengthy expression is also equivalent to the smallest one. So we want to reduce our Boolean functions such that we required a less number of logical gates to implement that particular function. So the first rule is the identity element. If we logical or a particular logical function, that is x, logical or with 0, that result is x, and x dot 1 is equal to x. And second law is the complementation law. If we have some Boolean function, Boolean variable, that is x, then plus with x dash, this plus represent the logical operation or. If we x or with x bar, that equal to 1, and x dot x bar, that equal to 0. Idempotency law, that is x plus x become x, and x dot x is also become x. Then there is some null law, that is x plus 1 is equal to 1. There is no impact on the output for this particular x. And x dot 0 is also become 0. Involution law, the complement of a complement particular variable, that is x bar, then again a bar is equivalent to the logical function, that is x. And commutative law, x or with y, that equal to y or with x, and x dot y is equal to y dot x. There is some associative law also, that is x plus y plus z, that equal to x plus y, then plus z. Then similarly x dot y dot z is equal to x dot y, then dot z. There is very important law, that is distributive law, that is x plus yz, x plus y dot z is equal to x plus y and x plus z. One more distributive law, that is x dot y plus z, that x dot y and x dot z. There is one more law, that is De Morgan law, very famous law, that is De Morgan's law. X plus y का complement is equal to x का complement and y का complement, plus converted into dot, dot converted into plus, variable converted into variable bar, and variable bar converted into variable. This is the complement law. Simplify the following, that if we have an expression that a plus b is equal to dot a bar dot b bar. First we multiply, we get a dash, b dash, and we again multiply that b, a dash and b dash. So we are using that a dot a bar is equal to 0. So it means that a dot a bar is equal to 0. So what is our result? That is 0, and 0 plus x become x, 0 plus x become x. So 0 plus x, that become x. So result is this b a dash b dash. So we can write this particular expression b a dash is equal to a dash b using commutative law. So we can write this as a dash b dot b dash, then again b dash b dot b dash is equal to 0. So we put here, that is a bar dot 0, or we x dot 0 become 0. So result is 0. So we simplify this particular expression. This is a long expression. It required one OR gate, one NOT gate, one NOT gate, and one AND gate. So what is the output? Output is 0. So this particular function has validity is it produce only 0. It is not depend upon A or B. So we simplify the following the expression, then which comes the output. It required the less number of logical gate to implement this particular function. Again, we take second example, that is A dot B dot C plus A dash plus B dash plus C dash. We can use any of the formula which is given in this particular first slide. That is, we can use the distributive law, that is A plus A dash dot A dash plus BC distributive law plus B dash plus C dash. So what is the result of A plus A dash? A plus A dash become 1. So result is A dash plus BC plus B dash plus C dash. So what is the result of this if we apply a distributive formula here? So what is the result? That is A dash plus B dash and C plus B dash then plus C dash. Again this is 1. Then what is the result? A dash plus C plus B dash plus C dash. C plus C dash become 1. A plus B dash plus 1 plus X become 1. So we simplify this particular expression. We can try this particular numerical, that A dot B dash plus C ka whole dash. So first we apply the De Morgan's law. Then De Morgan's law suggests that X plus Y dash is equal to X dash dot Y dash. So we apply here X dash Y dash. Then we again expand this particular complement here. Then we get A dash plus B dash ka whole dash. Then again a rule, X dash ka whole dash is equal to X dash ka whole dash is equal to again X. So we reduce this, that is A dash plus B ka dot C ka dash. So this is the simplified result. So we required only one NOT gate, one OR gate and one AND gate. Simplify this. We multiply, we use distributed formula here. Then we get A plus A dash and A plus B. We use distributed formula also here. A dash plus A dash plus B. This is equal to 1. This is also equal to 1. Then 1 dot something is equal to something. 1 dot X is equal to X. So 1 dot A plus B. Then 1 dot A dash plus B. So what we get? Then A plus B dot A bar plus B. Again we use distributed formula here. What we will get? That is A dot A dash plus B, or A dot A dash become 0. Then 0 plus B, again result is B. We can simplify this particular expression. This is the simply a De Morgan's law, plus converted into dot, dot converted into plus, literal converted into literal ka bar, then literal bar converted into literals. So we can simply write that A dash plus B dash plus C dash. Similarly, A dash, B dash, C dash ka whole dash. Again we apply a De Morgan's law. So we get A double dash, B double dash, then C double dash. It means X ka bar become X. So A bar ka bar equal to A, then B dash dash, that equal to also B, and similarly it is C. So result is A plus B plus C. It is logical equivalent to 3 input OR gate. Then take one another example, that is A dot B plus A plus B ka dash dot B. We multiply this B inside, then what we will get, that A dot B and B dash dot B. B dash dot B become 0. Then AB plus 0. AB plus 0 become AB. Then AB ka dash that become dot converted into plus, lateral converted into lateral ka bar. Then again we use a distributed formula between them. Then what we will get, that is A plus A dash dot B plus A dash. This become 1 or 1 dot something, that we will get again B plus A dash. Then again B plus B dash become 1, 1 plus A dash. Result is 1 plus A dash, 1 plus something, result is 1 always. So what will be result? That is 1 plus A dash, that result is 1. Take another example, that is A dot B plus A dot B dash plus A dash B plus A dash B dash. So we take A as a common in between these two pairs, and we take common A dash in these two terms. So what we will get, that B and B dash, B and B dash. So what is the value of B plus B dash? That is 1. So we write here 1 and 1, 1 dot something, 1 dot A become A, or 1 dot A dash become A dash, or again A plus A dash become 1. You can try this particular numerical. That first we apply De Morgan's law, that is A dash plus B double dash. Then again a De Morgan law here. Then after that we will get A plus B plus A plus A become A, and plus B. Here A dash dot B. If we multiply this inside, then A dot A dash dot B plus A dash B dot B. B dot B again B, and A dot A dash become 0. 0 dot B become 0. So what we will get, that A dash dot B. There is some numerical comes that prove that the two following functions are equivalent. Then A plus A dash dot B is equal to A plus B. Take left hand side. Then we use a distributed formula here. If we apply a distributed formula, then A plus A dash and A plus B. What is the value of A plus A dash? That become 1. 1 dot A plus B. 1 dot A plus B become A plus B. So left hand side is equal to right hand side. So we prove the two following functions are equivalent. Hence proved. If we have this function A dash plus A dot B is equal to A dash plus B, take distributed formula, that A dash plus A, then A dash plus B, then A dash plus A become 1, or 1 dot something, that output is A dash plus B. Then AB plus BC plus CA is equivalent to A plus B and B plus C and C plus A. Then take right hand side. We take a right hand side, we multiply both the terms, then we get A dot B, B dot B, A dot C, B dot C, and again dot C plus A. B dot B become B. So what we will get? A dot B plus A dot C plus B dot C. We take B as a common, or we multiply by C plus A. We multiply C plus A. Again, the result is come. Then we multiply by C, ABC, then B dot C, then ACC, BCC, AAB, AB, double AC, ABC. So what is the value of C dot C become C, C dot C become C, A dot A become A, and A dot become A. So what we will get? That ABC, BC, AC, BC, AB, AB, AC, and ABC. So we know that X plus X become X. So ABC plus ABC become ABC. Then BC plus BC, BC plus BC become BC. AC plus AC become AC. AB plus AB become AB. So finally we have these following terms. Then we take AB as a common. Then what we will get? C plus 1. C plus 1 become 1. And 1 dot A dot B become AB. So what is the result? Result is AB plus AC plus BC, which is left hand side. So hence proved. Similarly, take one more example, that A dot B dash C dash plus A dot B dash C plus ABC plus A dot B dot C dash dot A plus B is equal to A. First, take right hand side. Take right hand side. That we take some common. Then we take A dot B dash, A dot B dash, A dot B dash. So then what we will get? C dash plus C, which is equivalent to 1. We take AB as a common. Then what we will get? C plus C dash, which is also equivalent to 1. And 1 multiplied by AB, result is 1. Or A dot B dash is multiplied by 1, result is A dot B dash. Then we take A as a common here. Then what we will get? If we take A as a common, then what we will get? B dash plus B and A plus B. B dot B plus B dash is equal to 1. So result is A dot A plus B. We multiply here A dot A plus A dot B. A dot A become A. Then A plus AB. What we can take common as A? 1 plus B. 1 plus B again 1. Then A dot 1. Result is A. Hence proved. Next question comes is standard sum of product. If we have some expression and we want to convert it into the sum of product terms, this particular Boolean function, that is f, is a function of x, y, and z. So we need this particular expression converted into a standard sum of product. So similarly, we check that there is some term of x, some term of y, but z terms is not here. Here is x term, z term, but y term is not there. There is some y term and z term, but x term is not there. The Boolean functions suggest that the function is of x variable, y variable, and z variable. So we need to convert this particular expression into the sum of product. So we write here x dot y dot 1 in place of z. In place of y, we put here 1. In place of x, we put here x. And we use a formula that a plus a bar is equal to 1. So we place that 1 here. In place of 1, we put a plus a bar. We required here z, some term of z. So we replace this particular 1 as a z plus z bar. And this particular one is replaced by y plus y bar. This particular term is replaced by x plus x bar. So what will be your terms? That is comes that z plus z bar, y plus y bar, x plus x bar, and we multiply inside. So we will get this particular. In SOP, we summarize this. X plus y and x plus y, that x plus x become x. So this is our result. We notate this particular expression into some summation form. Because the function is of 3 variables, so it comes 2 to the power 3 is equal to 8. It means there is some terms in digital, that is 0, 1, 2, 3, 4, 5, 6 and 7. There is total 8 possibilities. So we convert into standard SOP form is function, that is this. So we convert this as a summation of 7, 6, 5, 3, that is 3, 5, 6, 7. How we convert this expression into some base 10 values? So in SOP, we replace a literal as a 1 and literal bar as a 0. So what is this? This is the x. So we write here 1, 1, 1. In binary, 1, 1, 1 represent to 7. This particular expression is 1, 1, 0, which is decimal equivalent to 6. This expression is 1, 0, 1, which is equivalent to 5. And this particular expression is 0, 1, 1, which is equivalent to 3. So we write here in sorted order, that is 3, 5, 6 and 7. So we can easily convert the particular following expression into the sum of product. Take one more example. This is the expression, that is a dash plus b dash dot b plus c. And we want to convert this particular expression in POS, product of sum. So what we can do? Here is A terms and here is B terms, but C terms is not available. And in this particular expression, A term is not given. So we put here 0 because of x plus 0 become x. So we write here in place of C, we write here 0. In place of A, we write here 0. We know that x dot x ka bar is equal to 0. So we replace 0 with x dot x bar. What is absent here? That is part of C, that is C dot C bar. What is absent here? A, that is A dot A bar. Then now we apply a distributed formula. This is x, this is y, this is z. X plus y and x plus z. So these are the following terms. Any term is repeating? Any term is repeating? So we check that any term is repeating or not. So standard POS form. In POS form, the literal bar is denoted as 1 and literal is denoted as 0. So what is this particular term is 1, 1, 0. And what is this term? That is 1, 1, 1. What is this term? 0, 0, 0. And what is this term? 1, 0, 0. Which is decimal equivalent 4, decimal equivalent 0, decimal equivalent 7, decimal equivalent 6. So 6, 7, 0, 4, and then we write in the sorted order. So result is 0, 4, 6 and 7. If we want to convert directly POS into SOP, so we write here that is summation in all terms are in between 0 to 7. So we convert that. 0 comes here, so 1 comes, 2 is not there, 3 is not there, 4 is here, so 5 and 6 and 7. So there is 4 term in the summation. So we can say that ki SOP is a complement of POS in terms of set. How we compute a complement of a particular set? C dash is equal to universal set minus set. So what is our universal set? A function of 3 variable, that is x, y and z. So there is some universal set that is belongs to 0, 1, 2, 3, 4, 5, 6 and 7. Total possibility is 2 to the power 3, that become 8. If our function is of 4 variable, that is a, b, c and d, the total number of values is 2 to the power 4 is equal to 16. It means our universal set have the values of 0, 1, 2 up to 15. Change in SOP form. So what particular portion is required? That is y and z, and in this what is required? That is x. So we put here y plus y bar and z plus z bar and x plus x bar. So we multiply. Okay. Then again multiply these following terms. Then what is this our result? This is our result. If anything is repeating, we reduce that x plus yz. It means the formula is x plus x is equal to x. So what is the standard form? That is the standard form. That is the standard form, and we convert this that is 1 1 1 become 7, then 1 1 0 then become 6, then 1 0 1 become 5, and 1 0 0 become 4, and 1 0 1 1 become 3. We write in the sorted order, that is 3 4 5 6 and 7. So it can easily reduce into the standard form of expression. Thank you.